Dear students, welcome. Today I am going to start a new chapter, simple harmonic motion of dynamics. Simple harmonic motion. Simple harmonic motion. It is simply denoted by S.H.M. S.H.M means simple harmonic motion. What is simple harmonic motion? If a particle is said to execute simple harmonic motion if it moves in a straight line. If it moves in a straight line such that its acceleration is always directed towards a fixed point in the line. Suppose O is the fixed point, towards a fixed point in the line, and is proportional to the distance of the particle from the fixed point. What is called simple harmonic motion? A particle is said to execute simple harmonic motion if it moves in a straight line such that its acceleration is always directed towards a fixed point in the line and is proportional to the distance of the particle from the fixed point. The fixed point is called the center of force. Center of force or center of attraction, center of force. The fixed point is called the center of attraction. Let me write first the definition of simple harmonic motion. Simple harmonic motion definition. Definition. For your convenience, I am writing the definition of simple harmonic motion. A particle is said to execute simple harmonic motion. Simple harmonic motion. Or S.H.M. S.H.M means simple harmonic motion. If it moves in a straight line, such that its acceleration is always directed. Its acceleration is always directed towards a fixed point in the line. Towards a fixed point in the line. A particle is said to execute simple harmonic motion if it moves in a straight line, such that its acceleration is always directed towards a fixed point in the line and is proportional to the distance of the particle and is proportional to the distance of the particle from the fixed point. To the distance of the particle. From the fixed point. The fixed point is called the center of force. The fixed point is called the center of force. Center of force. What I have written, a particle is said to execute simple harmonic motion if it moves in a straight line such that its acceleration is always directed towards a fixed point in the line and is proportional to the distance of the particle from the fixed point. The fixed point is called the center of force. Suppose a particle starts from A. From rest. From rest means its velocity equal to 0. The velocity of the particle at A is 0. It is directed towards the center of force. It is directed towards the center of force. Suppose P is the distance OA. This distance is A. Suppose this distance is A. Suppose P is the position of the particle at any time P, where OP equal to X. OP this is equal to X. Let me write. This is equal to X. By the definition of simple harmonic motion, the acceleration of the particle at the point P should be equal to some constant into X, because it is acceleration is proportional to the distance of the particle from the fixed point, and it is directed towards O. Let the particle start from the point A. Let the particle starts from the point A. Point A. Where OA equal to A. Where OA equal to A. O is the center of force. O is the center of force. Where O is the center of force. Center of force. This is the origin is taken as the center of force. O is the center of force. Let P be the position of the particle at line P. Let P be the position of the particle. Let P be the position of the particle at time P, where OP equal to X. Now, by the definition of simple harmonic motion, the acceleration at P should be equal to a constant into X. By the definition of simple harmonic motion, by the definition of simple harmonic motion, the acceleration at P is mu X. Definition of simple harmonic motion, the acceleration at P is mu X, where mu is constant. Mu is constant. This constant is called the constant intensity of force, which is called the intensity of force. Which is called the intensity of force. Mu is a constant. This is called the intensity of force, mu X. The particle is attracted towards the center of force P. Also, the particle is attracted. Towards the center of force. Towards the center of force O. Towards the center of force O. Therefore, the equation of motion of the particle is given by equation of motion of the particle is given by x double naught. X double naught stands for the acceleration of the particle at P. X double naught means d2x by dt square. You may write x double naught or d2x by dt square. You may write d2x by dt square equal to minus mu x. We have taken the negative sign. You see, we have taken the negative sign because you may write here the negative sign has been taken. Negative sign has been taken. Since the acceleration is directed towards O, is directed here. Towards O, that is in the direction of x decreasing. That is in the direction of x decreasing. X decreasing. That is in the direction of x decreasing. The negative sign has been taken. Since the acceleration is directed towards O, that is in the direction of x decreasing. But x double dot means d2x by dt square is the mathematical expression for acceleration. Is the mathematical expression for acceleration. Expression for acceleration in the direction of x increasing. In the direction of x increasing. The negative sign has been taken since the acceleration is directed towards, so that is acceleration is in the direction of x decreasing. But x double dot means d2x by dt square is the mathematical expression for acceleration in the direction of x increasing. Therefore, we have taken the negative sign. We have taken the negative sign. Now, this is a differential equation. It is a differential equation of order 2. It is very easy to solve this differential equation. You may write d2x by dt square. It is nothing but the rate of change of the velocity, dv by dt. You may write here dv by dt or dv by dt also. Also, you may write dv by dt can also be written as v dv by dx. We cannot write dv by dt because the right hand side is x. We should write v dv by dx. Then you will get a differential equation of first order and first degree. Two variables, v and x. Such type of problems have already been done in motion in a straight line with variable accelerations. You may see my videos. Now, you may, this is a differential equation. Just to solve the differential, it is very easy to solve this differential equation. First, you should multiply this differential equation by 2 times of dx by dt. Now, multiplying by 2 times of dx by dt we get. Now multiplying by 2 times of dx by, now multiplying, suppose this is number 1. Suppose this differential equation is number 1. Multiplying 1 by 2 times of dx dt we get. Multiplying 1 by 2 times of dx by dt we get. 2 times of dx by dt d2x by dt square equal to minus mu x into 2 times of dx by dt. You may write like this. Now, this means d dt of dx by dt whole square. Left hand side, you may replace this by this. Now differentiate this with respect to t. 2 times of dx by dt. Again differentiate dx by dt with respect to the d2x by dt square. Simply 2 times of dx by dt, d2x by dt square can be replaced by d dt of dx by dt whole square. Similarly, d dt of minus, it is minus x square, minus mu x square. D dt of minus mu x square. Now differentiate this minus mu twice x dx by dt. You are differentiating with respect to t. Now integrating we get. With integrating we get with respect to t. Integrating we get. Integrating we get dx by dt whole square equal to minus mu x square plus c1. Suppose this is c1, where c1 is the constant of integration. Where c1 is the constant of integration. Integrating we will, but dx by dt stands for the velocity. You may write it as velocity also. Velocity, v square. You may write dx by dt equal to v, because rate of change of displacement is called the velocity. V square, it is velocity. C1 is the constant of integration. Where C1 is the constant of integration? Is the constant of integration. Where C1 is the constant of integration. Now you see, initially the particle starts from the point A. Starts from the point A means the velocity of the particle at the point A, this is equal to 0. And then the distance x, what is the distance x? Just the distance of the particle from the center of force O. It is OA equal to A. But initially at A, dx by dt, or if it is v equal to 0, when x equal to OA equal to A, x equal to A. Initially, dx by dt equal to 0, x equal to A. Therefore, from 2 you will get, you may write 2 implies. Means from 2 we get 0 equal to minus mu a square plus c1, or c1 equal to mu a square. C1 equal to mu a square. Substitute the value of c1 into substituting this value, substituting this value of c1 into we get, substituting this value of c1 into we get v square equal to minus mu x square plus mu a square. V is the velocity of the particle at the P, where V is the velocity of the particle at P. Or V square equal to mu a square minus x square. This is a very important relation of simple harmonic motion. You should remember this relation. V is the velocity of the particle at P, where V is the velocity of the particle at P. V is the velocity of the particle at P. That is, V is the velocity of the particle when it is at a distance x from the center of force. V is the velocity of the particle when it is at a distance x from the center of force. That is, V is the velocity of the particle where V is the velocity of the particle when it is at a distance x from the center of force. When it is at a distance x from the center of force, That is, v is the velocity of the particle when it is at the distance x from the center of force. Just remember this relation. It is a very important relation. You should always remember this. V square equal to mu into a square minus x square. What is A? We shall define it later on. A is called the amplitude. What is amplitude? We shall discuss it later on. A is called the amplitude. Now V square is equal to mu into a square minus x square. Now you see here, if you put x equal to 0 here, then from this relation, velocity is maximum. Velocity will be maximum when x is equal to 0. A square minus x square. A square minus x square. If x is equal to 0, velocity is maximum. Now, when from 3, putting x is equal to 0, putting x is equal to 0 from 3, putting x is equal to 0, we get v square equal to mu square. This means v equal to a root over mu. When x is equal to 0, the particle is at the point O. But when x is equal to 0, the particle is just we are measuring x from O, center of force. If the particle is at P, the distance is x. If the particle is at the point O, means the particle is at the center of force O, then the velocity is maximum. When x is equal to 0, the particle is at the center of force. O. But the particle is at the center of force O. But when x is equal to 0, the particle is at the center of force O. And at the point O, the velocity is maximum. And at the point O, the velocity is maximum. That is in simple harmonic motion, the velocity of the particle is maximum at the center of force. That is in simple harmonic motion. Thus, in simple harmonic motion, the velocity is maximum at the center of force. But thus in simple harmonic motion, the velocity is maximum at the center of force. And the maximum velocity is a root mu. And the maximum velocity is a root mu. This is the maximum velocity. And velocity is maximum. A root mu is the maximum velocity of the particle in simple harmonic motion. And the velocity is maximum at the center of force. Now, from 3, put v equal to 0. Again, from 3, put v equal to 0. Again, in 3, put v equal to 0. Again, in 3. Put v equal to 0. Put v equal to 0 here. You will get v 0 equal to mu into a square minus x square. This means x square equal to a square. Means x is equal to plus minus a. X is equal to plus minus a. This means that the velocity of the particle becomes zero at 2 points, when it is at the distance a and when it is at the distance minus a from the center of force O. Thus the velocity of the particle is zero at 2 points. This is A. Therefore the velocity of the particle becomes zero at 2 points. At 2 points, where at x is equal to a and x is equal to minus a. In these 2 points, the velocity of the particle becomes zero. Now you see, at the point A, the velocity is zero of the particle is zero. Suppose this is a dash, and this distance is again a. And at the point A dash also, the velocity is equal to zero. At this point also, the velocity is equal to zero. And the numerical value of the distance from 0 to A dash is again A. And it is the origin. If it is plus A, it is minus A. It is minus A, like that. Now you see here. Now, from 3, you should remember this number 3. From 3, we have calculated again we have derived 2 conditions. The velocity is 0 at 2 points. X is equal to A and x is equal to minus A. At the point A, the velocity is 0, and at the point minus A dash also, the velocity is 0. Also, putting x equal to 0, we have obtained the maximum velocity of the particle, which is root over mu A, and the velocity of the particle is maximum at the center of force. Now from 3 we get, from 3, V equal to negative sign, we have again written the negative sign. V stands for the velocity of the particle. Here also we have taken the negative sign. V equal to the negative sign. The velocity, the negative sign has been taken. Or for V you may write dx by dt. You may write dx by dt equal to V equal to minus root over this. Here also negative sign has been taken, because the negative sign has been taken. The negative sign has been taken because the particle is moving in a direction of x decreasing. Since the particle is moving in the direction of x decreasing, but dx by dt is the mathematical expression of velocity in a direction of x increasing. The particle is moving in this direction. Particle is moving in this direction. The velocity increases when x decreases. And is moving in the direction of x decreasing. But dx by dt is the mathematical expression of velocity mathematical expression of velocity in the direction of x increasing. In the direction of x increasing. X increasing. X increasing. The negative sign has been taken. Now, from here, you may write dx by root of r. This is a differential equation. Root of r mu dt. And negative sign. You may put the negative sign here also. You may put the negative sign here also. Now the variables have been separated. Integrating we get. Integrating we get. We get integration minus dx by root of r. A square minus x square equal to root of r mu dt plus c2, where c2 is the constant of integration. Where c2 is the constant of integration. Is the constant of integration. Where c2 is the constant of integration. Now what is the integration of this? This means cos inverse x by a equal to root of r mu t plus c2. Cos inverse x by a. You may write minus here. Then sin inverse x by a equal to minus root of r mu t plus c2. Then initially the constant of integration will be found from the initial condition. Initially at the point a, x equal to a, t equal to 0. At the point a, the particle starts. This means that t equal to 0. Here x equal to a means cos inverse 1. The cos inverse 1 means it is 0. Cos inverse 1 means 0. If you put negative sign here, then you will get sin inverse x by a equal to minus root mu t. Then initially x is equal to a, sin inverse 1 equal to minus root mu t plus c2. Then you will get that c2 equal to pi by 2. Sin inverse 1 means pi by 2. Here you will get 0. Cos inverse 1 means 0. C2 equal to 0, then you will get pi by 2. Same result. You will get the same result. Now you see. This means, suppose this is number 4. Let me write this number 4. Initially at a. Initially at a. X equal to a when t equal to 0. When t is equal to 0. Therefore 4 implies. From 4 you will get cos inverse 1 equal to 0 plus c2. This means c2 equal to 0. Put the value of c2 in 4. Then you will get cos inverse x by a equal to root over mu t. This means x equal to a cos root mu t. This is also another important relation of simple harmonic motion. X is equal to a cos root mu t. Just as before, I have mentioned that note. You need not write this one, but I am giving you these things because you may write like this also, minus root mu t. Root mu dt. Now integrate this. Suppose this is C2. Then you will get sin inverse x by a equal to minus root mu t plus C2. Initially, x is equal to a, t equal to 0. Therefore, C2 equal to, you will get pi by 2 here. Because it is sin inverse 1, 0, C2. Since sin inverse 1 equal to pi by 2. Sin inverse 1 equal to pi by 2. Pi by 2. Now put the value of this one, sin inverse x by a equal to minus root mu t plus pi by 2. This means that pi by 2 minus sine inverse x by e equal to root mu t. You will get this one. Now you know that sine inverse x plus cos inverse x equal to pi by 2. Tan inverse x plus cot inverse x equal to pi by 2. Like that. Sine inverse x plus cos inverse x equal to pi by 2. Means pi by 2 minus sine inverse. This can be replaced by cos inverse x by 2. This means cos inverse x by 2 equal to root mu t. You will get the same result. This means x equal to a cos root mu t. X is equal to a cos root mu t. You will get the same result. Now remember this, x equal to a cos root mu t. In simple harmonic motion, you should remember from definition, x double dot equal to minus mu x, number 1. Number 2, v square equal to mu into a square minus x square, number 2. Number 3, x equal to a cos root mu t. Also, we have obtained the relation that the velocity of the particle is maximum at the center of force, and it was derived from the relation v square is equal to mu into a square minus x square, and the maximum velocity is root over mu a, like that. Now you see, now I am going to write something. Consider the form. The velocity of the particle becomes zero at 2 points, at A and A dash. Now you see, note. The velocity of the particle becomes zero at 2 points. The velocity of the particle becomes zero at two positions. X is equal to A and x is equal to minus A. That is at the points. In the diagram, A and A dash. That is at the points A and A dash. O is equal to A. Also, O A dash is also A. But it is in the negative direction, therefore O A dash can be written as minus A. At O. Now from the motion from A to O, consider the for the motion of the particle from A to O, for the motion of the particle from A to O. Here you see the velocity of the particle at A is equal to 0. The velocity increases for the motion of the particle from A to O. The velocity of the particle increases and at the point O, its velocity becomes zero. It becomes maximum. Its velocity becomes maximum, and the maximum velocity is of the particle is root over mu a, and the maximum velocity of the particle is root over mu a. The velocity of the particle is maximum at the center of force, and the particle keep on moving towards O dash, and the particle keeps on moving, and the particle keeps on moving towards or along O dash, along O dash. But since the particle is attracted towards O, its velocity will be decreasing from O to O dash. But since the particle is attracted towards O, particle is attracted towards O. But since the particle is attracted towards O, the velocity of the particle, it is attracted towards O, the velocity of the particle will be decreasing, will decrease from since the will decrease from O to A dash, but at the point A dash its velocity becomes zero. But at the point A dash, the velocity of the particle, but at the point A dash, the velocity of the particle becomes zero. Becomes zero means it will, that is, the particle will stop at A dash. That is, the particle will stop at A dash. The particle will stop at A dash. But it is attracted towards O. But it is attracted towards O. Therefore, it will start moving along A dash O towards O. Therefore, it will start to move. I am writing here. It will start to move along A dash O. It is attracted, and the velocity of the particle will be increasing A dash O, and the velocity of the particle goes on increasing from A dash to O, and at the point O, its velocity becomes maximum. And at the point, and when it arrives at O, the velocity of the particle will be maximum. The velocity of the particle will be maximum. velocity of the particle will be maximum. The velocity of the particle will be from A dash to O, the velocity of the particle will increase, and when it arrives at O, its velocity will be maximum. And the particle will continue to move along OA, because there is a velocity here. It will move along OA. But it is attracted towards O. Its velocity goes on decreasing from O to A. But the particle is attracting. Towards O. But the particle is attracted towards O. Therefore, the velocity of the particle goes on decreasing from O to A, and when it arrives at O, arrives at A, the velocity of the particle becomes zero. Particle becomes zero when it arrives at A, the velocity of the particle. You see, at the point A, its velocity is zero. It will move towards O, and at the point when it arrives at the point O, its velocity is maximum, and it will go from O to A dash, and its velocity will be decreasing, and when it arrives at the point A dash, its velocity becomes zero. Again, it will move towards this one, towards A, and at the point A, its velocity again zero. It will continue to move from A to A dash. The particle will continue to move from A to A dash. The particle will continue to move between A and A dash. It is the motion is repeated over and over again. The motion is repeated. Over and over again. Such type of motion is called simple harmonic oscillation. Such type of motion is called simple harmonic oscillation. Motion is called simple harmonic oscillation. Now I am going to give you some definitions. It will continue to move from A and A dash. It will move like this, A and A dash. Now definition. Amplitude. Definition amplitude. The distance of the particle The amplitude in simple harmonic motion, the distance from the center of force of the maximum displacement of the particle is called the amplitude. In simple harmonic motion, S.H.M. S.H.M means simple harmonic motion. The distance of the distance the distance between the center of force and one of the position of rest, between the center of force. What is the maximum displacement? Here, the distance between the center of force and one of each positions of one of each. There are two positions of rest. One of each positions of rest is called the amplitude. Called the amplitude of motion. Is called the amplitude of motion. In simple harmonic motion, the distance between the center of force and one of its position of rest is called the amplitude of motion. Here the amplitude is OA. Here OA equal to the amplitude. A is the amplitude of motion. OA, this distance is called the distance always result from the center of force. Maximum displacement. Where is the maximum displacement? When the particle arrives at A, this is the maximum displacement of the particle from the center of force. This is the amplitude of motion. OA is the amplitude of motion. Now I am going to give you one definition which is called the periodic motion or time period. Definition. Next definition. Time period or periodic time or simply period. Time period, periodic time or simply the time table in simple harmonic motion. In simple harmonic motion, the time taken by the particle for one complete oscillation. In simple harmonic motion, the time taken by the particle for one complete oscillation is called the periodic time. Periodic time or time period or simply period or period. That is the time taken by the particle from A to A dash and back to A is called the time period. That is the time taken by the particle from A to A dash, and then back to A is called the time period or periodic time or simply period. From A, if the particle starts from A to A dash, then to A, from A to A dash and from A dash to A, the total time taken by the particle. This is called the periodic time. Time period is generally denoted by capital T. The time period is denoted by capital T. Time taken is denoted by capital T. Time taken. Now you see here, we have already obtained that. We have already obtained that dx by dt equal to minus root over mu root over a square minus x square. We have obtained this relation. These relations can be found from the relation v square equal to mu into a square minus x square. V square is equal to mu into a square minus x square. The negative sign has been taken because the particle is moving in the direction of x decreasing. Dx by dt equal to minus root mu into root over a square minus x square. Or you may write dx by root over a square minus x square. This is equal to minus root mu dt. Suppose I have forgotten the number. You may write here it is just star. Suppose. What is the time taken by the particle? From A to A dash and A dash to E, late. Time taken by the particle. Taken by the particle. From A to O. This is equal to time taken by the particle. From O to A dash. This is equal to time taken by the particle. From A dash to O. This is equal to time taken by the particle. From O to A. This is equal to T1. Suppose this is equal to T1C. All time will be same. The time taken by the particle from A to O. This is equal to time taken by the particle from O to A dash, and it is equal to from A dash to O, and the time taken by the particle from O to A. Suppose that time taken by the particle from A to O equal to T1. All this is T1. Now we are going to find the time taken by the particle from O to A. O to A. Motion from O to A. Now we may write motion of the particle from O to A. Motion of the particle from A to O. A to O. Suppose motion of the particle from A to O. Integrating star we get. Integrating star we get. Star we get. Integrating star we get dx by root over a square minus x square equal to root mu dt x equal to, here it is t equal to. You see, at the point A, t equal to 0. And at the point A, what is x? The particle, when the particle is at the point A, then x is equal to small a. And it is t1. When it arrives at the point O, the time taken by the particle is t1. And it is 0 when the particle arrives at this is equal to 0. Or you may write by applying the property of definite integral. Apply the property of definite integral. X is equal to a to 0. X is equal to a to 0. From a to 0, a to O. Then t equal to 0 to e. Thus interchange the limit here. Then the negative sign is, if you interchange this, a negative sign should be there. Therefore, here 0 to t1, t equal to 0 to t1, root mu dt, you may write like this. We have written the negative sign here, negative will be cancelled, just you may write like this. Or it is nothing but sine inverse x by e. 0 to a, this is equal to root mu t1, it will be root mu t1. Root mu t 0 to t1 means t1 minus 0 means it will be t1. Or or sine inverse 1 minus sine inverse 0 equal to root mu t1. This means pi by 2 minus 0 equal to root mu t1. This means t1 equal to pi by 2 times of root mu. Pi by 2 times of root mu. Therefore, time period capital T is given by T is equal to 4 times of T1. What is T1? A to O equal to O to A, there's 2 times of T1, A dash to O, 3 times of T1, O to A, 4 times of T1. This is equal to 4 into pi by 2 root mu. This is equal to twice pi by root mu. Therefore, T equal to twice pi divided by root mu. T is equal to twice pi divided by root mu. This is the expression for periodic time or time period. You should remember this also. Just remember. T is equal to twice pi by root mu. So we have already obtained a relation in simple harmonic motion. X is equal to a cos root mu t. X is equal to a cos root mu t. Here also you may write x is equal to when it arrives at O, then x is equal to 0. And a cos root mu, it is t1. From A to O, if it takes time t1 from A to O, you will get this one. Or you may write cos of root mu t1 equal to 0. What is 0? 0 means cos pi by 2. This means root mu t1 equal to pi by 2. This means t1 equal to pi by 2 root mu. T is equal to 4 times of t1 equal to twice pi by root. That's the in a simple way you may write this also. Perhaps you have understood what is time period or periodic time. Periodic time, you should remember always that periodic time of simple harmonic motion is given by twice pi by root mu. Now, I am going to give you another definition which is called the frequency. The number of complete vibration executed by a vibrating body in 1 second is called the frequency of the body. In 1 second, the total number of complete oscillation. The number of complete oscillation in 1 second is called the frequency. The number of complete oscillation is in 1 second. or in 1 second, in 1 second is called frequency. Frequency is denoted by m. Frequency is generally denoted by m. Clearly, obviously, n equal to 1 by t. In 1 second means n into t will be equal to 1. N should be equal to 1 by t. Frequency, the relation between frequency and time period, n equal to 1 by t. Therefore, the expression for frequency will be equal to root mu divided by twice pi. It is root mu divided by twice pi. Therefore, n equal to 1 by t. We have defined the time period, amplitude and frequency also. Dear students, perhaps you have enjoyed the class. In the next class, we shall try to solve some problems on the simple harmonic motion. The problems are very interesting and very easy. Next time we shall solve some interesting problems on simple harmonic motions. Today I want to stop here. Thanks for attending the class. Thank you very much. Thank you very much.